Welcome to the third part of this lesson. In this lesson, we're going to be going through questions like these. Let's just look at this first one here. It says solve sine of 2 theta is equal to negative 1 over the square root of 2 for theta is an element of 0 to 2 pi. Hopefully what you notice here is what makes these questions different to what we've seen in previous parts of this lesson is this coefficient in front of our theta. So to over here, we have theta divided by 2. So it's quite clear what is different here. And how are we going to address this? Well, what we're going to do is I'm just going to bring up this PowerPoint just to really help us visualize what's going on here. And what we're really doing here is we're solving equations of the form. And as you can see here, we have a coefficient inside our brackets here. And that's really going to affect things. Okay, so here's the question that we just saw before. How are we going to visualize this? Well, let's just start off with what we know. Let's draw our axes and let's just draw y equals sine of theta. We can do that. And again, let's also draw in this right here. So y equals negative 1 over the square root of 2. That's going to be here. And as you can see, if I was just to solve this, I would end up with 2 points of intersection. So therefore 2 solutions. But I need to draw sine of 2 theta, not just sine of theta. So let's now draw sine of 2 theta. Now, what does this 2 actually do? We know, based on our transformations, that that is going to cause a dilation from the y-axis by a factor of 1/2, because remember, you take the reciprocal of it. So that means we're actually going to be pushing it towards the y-axis, which means I actually have 1, 2, 3, 4 solutions. So 2 here and 2 here. And that is the important part here. So in the previous part, we learned that by increasing our domain, we get more solutions. Well, so too, when we start altering things inside our bracket, we can also increase or decrease the amount of solutions we're going to be getting. And I'm going to be showing you a tactic that we can use, a technique that is really going to help us answer this in the most efficient way possible. Okay, so let's get stuck into it now. So let's move this up here and let's go through it. Perfect. All right. When we're given a question like this, the first thing that we're going to do is we are going to do something that you might think, oh, why are we doing that? But this is what we're going to do. We're going to say let x equal 2 theta. Now, it could be any pronumeral you want. It could be w, it could be t, whatever. It doesn't matter. But we're just going to say let what is inside our brackets here be equal to some pronumeral. Now, what we're also going to do is we're going to say, all right, if this is theta is an element of 0 to 2 pi, and we know that x is equal to 2 theta, what if I multiply this by 2, which would therefore mean I have to also multiply these by 2. If I multiply this by 2, I have to also multiply these by 2. So I'm going to get 2 theta is an element of, well, 0 times 2 is just 0, and then this will be 4 pi. Now that I've done that, well, if x is equal to 2 theta, that means 2 theta is equal to x. So I can just write it like this. So that is really important, what we're doing with our domain here. Then, if I know that x is equal to 2 theta, I can now rewrite this as sine of x is equal to negative 1 on the square root of 2. And just like that, I can now deal with this. This is just like doing any other question. And hopefully you can see what we've done here. By extending the domain, we know that we're going to get 4 solutions for a question like this. So this is really like a hack, a technique, a little trick that we can use to find all those solutions without having to go through all the trickiness of the fact that what's inside our bracket has changed. Hopefully that made sense. But as long as you follow this procedure, you're going to be fine. So now that we've done that, we're going to think of our unit circle. And we're going to say we're dealing with sine, which is my y-axis, and it's negative value, so it's going to be there. So that means I'm going to be in my 3rd and 4th quadrant. I also need to figure out what my reference angle is going to be. So I'm going to draw myself my special triangle and go to, actually, I don't have to do this, do I? That's the wrong triangle anyway. I know my reference angle immediately is going to be pi on 4. Just by looking at 1 on the square root of 2 is going to be pi on 4. All right, so we've done some important things here. We know our reference angle is pi on 4, and we know I'm looking at the 3rd and 4th quadrant. So I'm going to say x is equal to, now, my reference angle isn't going to be one of it because I don't have my 1st quadrant, but my 3rd quadrant is going to be 5 pi on 4. And then in this, my 4th quadrant, it will be 7 pi on 4. But then remember, because I have to go let me get another color here. I have to go 4 pi around the circle. So that's 2 pi here. So that covers those ones right there. But now I have to do another loop around 4 pi loop to get my other two solutions. So to do that, I'm going to take this, I'm going to plus 2 pi. I'm going to take this and I'm going to plus 2 pi. So that means I'm going to end up with, you might be able to do this in your head, because I know that this is going to be 8 pi on 4. So I might rub this out later, but I'm going to do this, 8 pi on 4, which is going to be 13 pi on 4. And then I'm going to rub this out. So it's probably not a good idea for you to write it, because I want our working to be nice and neat. This is just going to make it a little bit messy. That's going to be 15 pi on 4. Perfect. So now that I've got those, the next thing that I'm going to do is, whenever you're given an answer, a question, in this case, as you can see, it's in terms of theta. You can't give an answer in terms of x. You know, that's not allowed. Your answer has to be in terms of theta. So the next thing you're going to say is, well, I know that x is equal to 2 theta, right? Because that's what we stated at the beginning. So that means all of these are going to be the same. So I'm not changing anything here. I'm going to do it all in red. So now my answer is theta is equal to, but I've got that 2 there, and I need to get rid of that coefficient of 2. To do that, I'm going to times it by a half, which means I'm going to times each of these also by a half. I have to. And what that means I'm going to end up with is theta is equal to 5 pi on 8, 7 pi on 8, 13 pi on 8, 15 pi on 8. Those are my solutions. And we got them by doing that process. And remember, because our question had theta in it, our answer has to be theta is equal to. You can't change it. And that's how we would approach a question like this. I now want to show you on Desmos what we've just done, and hopefully that will actually help us as well. So we just drew this. So this is sine of 2x. Our domain is 0 to 2 pi. And this is our line. So this blue thing right here. And as you can see, our answers are 5 pi on 8, 7 pi on 8, 13 pi on 8, and 15 pi on 8. And those are the answers that we got. 5 pi on 8, 7 pi on 8, 13 pi on 8, and 15 pi on 8. So as you can see, it's just those intersection points. There you go, 5 pi, 7 pi, 13 pi, 15 pi, all on 8. Perfect. All right, let's bring this back up and let's go to our next question here. So we're up here now, we're looking at this. All right, so the first thing that we do is we let x, let's actually let it be something else. Let t, could be whatever you want, be equal to that. So what's inside our brackets there. And if we were to do that, I'm going to have to change my domain. So my domain is going to have to be times by a half, which means this is going to have to be times by a half. This is going to have to be times by a half. So it's going to be theta pi on 2 is an element of 0 to pi. And then I'm going to rewrite it as 2 cos of t minus the square root of 3 on 0. And now my domain is, I know theta on 2 is t, is an element of 0 to pi. Cos of t is equal to the square root of 3 on 2. And I'm just going to rewrite my domain again. All right, so once I'm here, now I need to just figure out what my reference angle is going to be and also what quadrants I'm dealing with. What is my reference angle? Hopefully just by looking at that, you can see that it's going to be pi on 6. But if you needed to, remember, you can draw your special triangle to help you out here. 2, 1, square root of 3. So obviously it's going to be up here, pi on 6, because adjacent over hypotenuse. And then your unit circle as well, if we just think about this for a moment, it's cos, so it's my x, it's going to be here, so I'm from there to there, so it's in my first and my fourth quadrant. But then also be careful, this is where you have to actually look at your domain here. My domain is just simply 0 to pi. So my fourth quadrant isn't even involved. I'm just looking at my first quadrant. So that means my answer is going to be t, because remember I put t here, is equal to just pi on 6, because I'm just looking in this first quadrant. And then once I've done that, remember now you have to swap it back to what you originally said t was equal to. So I said t was equal to theta on 2. So I'm going to go theta on 2 is equal to pi on 6. And now I need to get it just in terms of theta. So that means I'm going to, let me do this in green. Multiply this by 2, multiply this by 2. I'm going to get theta is equal to 2 pi on 6, which is the same as pi on 3. And that's how we approach that. So that is our answer there, just pi on 3. So as you can see here, we only have one solution, but that's fine. If I just quickly show you what we've done here, let me just bring this here. So this time we graphed this, cos of x on 2 from 0 to 2 pi. Then we had this, y equals the square root of 3 on 2. And as you can see here, it has one point of intersection at pi on 3. Perfect. Let's now go on to our next question. So now we are down here. We're dealing with a tan in this time. Okay, so the first thing that we're going to do is we're going to go remember any pronumeral, just go w. Let w equal 2 theta, in which case I'm going to have to times this by 2, this by 2, this by 2. So I'm going to get 2 theta is an element of negative 2 pi to 2 pi. Now I'm going to rewrite this with w there. Tan of w is equal to the square root of 3. Now 2 theta is equal to w, so I can say w is an element of negative 2 pi to 2 pi. And now what I'm going to do is I'm going to figure out what my reference angle is going to be. Hopefully you can immediately just recognize it's going to be pi on 3. And we're going to look at our unit circle and say, all right, whoops, let me just see if I can do that a bit nicer. There's pi on 3, and there's the other place it's going to occur. So pi on 3 is going to occur there. So tangent, when tangent equals pi on 3, is going to happen twice, here and also here. So yeah, tangent, sorry, let me say that again. Tangent of the square root of 3 is going to happen here, and it's going to happen in my third quadrant. So I'm going to get the output of square root of 3 for tan in two places, in the first and third quadrant. So my reference is pi on 3, because in my first quadrant I know that's going to be pi on 3. And then once I've done that, now I need to figure out what w is going to be. So I know that now I've got negative. Ugh. So let me just leave some gaps here. I know the first one is going to be pi on 3. And then here, it's going to be my third quadrant, which is going to be 4 pi on 3. So that is going from there to there, there to there, so those two. But now I have to go backwards. I have to go here to here, then here to here. Now there is a couple of different ways of going about it. I think the slow way, but the way that would work, would be going, I'm taking that and I'm minusing 2 pi. And I'm taking this and I'm minusing 2 pi. Or if you wanted to, you could think, well, if I'm going back to here, right, to here, this is kind of like being in my second quadrant, but backwards. And I know in my second quadrant it's going to be 2 pi on 3, but because I'm going backwards, it's going to be negative 2 pi on 3. I think that's the quickest way to do it. So this one right here is going to be negative 2 pi on 3. And that would be the same as subtracting 2 pi from that. And if I am going all the way to here, this is like my fourth quadrant, right? But I'm going backwards. My fourth quadrant is going to be 5, no, what am I doing? I'm going pi on 3, so it's going to be 5 pi on 3, so it's going to be negative 5 pi on 3, because I'm going backwards. If that doesn't make any sense, just take this, subtract 2 pi. Take this, subtract 2 pi, and you'll get your answer. All right, once we've done that, we now need to swap back what we had. So now I have to go, what did I originally say w was equal to? I originally said w was equal to 2 theta. So I'm going to get 2 theta is equal to, and now I'm just going to rewrite everything. And then once I've done that, now I need to get rid of that 2. So I'm going to times everything by 1/2. So I'm going to end up with theta is equal to negative 5 pi on 6, negative 2 pi on 6, pi on 6, 4 pi on 6. I need to simplify some of these. This is going to be negative pi on 3, pi on 6, and this is going to be 2 pi on 3. So that's going to be my answer. If I was just to quickly show you what this is going to look like, so our tan graph is different. This is tan of 2x. Here is y equals the square root of 3. And as you can see, 5 pi on 6, negative 5 pi on 6, negative pi on 3, pi on 6, 2 pi on 3. And those are the answers that we saw in that we just got. So as you can see, negative 5 pi on 6, there's 2 pi on 3. I'm going to have to shrink this. Oh, did that work? Did they go away? They went away. Let me just click them again. So as you can see, they are all the same to what we got there. So they're just the point of intersections of that. All right, last one. Doing this one right here. All right, so I'm going to get, I don't know, A be equal to what's inside my brackets here, so 3 theta. I actually don't like it when it's written like this, so I'm just going to rewrite it, but I'm doing the same thing here. I'm timesing everything by 3. Is theta is going to be an element of 0 to 6 pi, right? 2 sine of A plus 1 equals 0, and my theta, sorry, this should be 3 theta because I times it by 3, and now I know that 3 theta is equal to A. I can say A is an element of 0 to 6 pi. Now I have to rearrange this. It's going to be sine of A is equal to negative 1 on 2, and let me just rewrite my domain here. Okay, once I've done that, I need to now figure out what my reference angle is going to be, and also which quadrants this is going to appear in. So let me just do that. Let me try that again. All right, that's as good as it's going to get. It's sine, so that means I'm dealing with my y. It's negative, so I'm down here. It's going to be here and here, so it's going to be in my 3rd and 4th quadrants. In terms of what my reference angle is going to be, if you need help with this, just draw your special triangle. 2, 1, square root of 3. I need to get a half. It has to be opposite over adjacent because it's sine. So it's going to be here, which is going to be pi on 6. So that means my reference angle, and always write down what the reference angle is going to be, is pi on 6. And then I'm going to go, A is going to be equal to, well, if my reference angle is pi on 6 and I'm in my 3rd quadrant, that means it's going to be 7 pi on 6. And then to go to my 4th quadrant, it is going to be 11 pi on 6. Okay, and now this is where it gets tricky. This is 6 pi. That means I'm going 3 times around. I'm going 3 times around my unit circle. So this is going to be a lot of adding here to get this right. So I'm going to have to plus 2 pi onto this to get my next one. So that's going to be 7 pi on 6 plus 12 pi on 6, which is going to be 19 pi on 6. And then I'm going to take this one and I'm going to plus 2 pi to that. So 11 pi on 6 plus 12 pi on 6 is going to be 23 pi on 6. So remember what I'm doing here. I might just do one example here, just in case you're thinking, what on earth is he doing? I take 7 pi on 6, so that's this one right here, and I'm plussing 2 pi. But remember, my denominators need to be the same. So it's going to be 12 pi on 6, because that's the same as 2 pi. And then that's going to end up being 19 pi on 6. That's what I'm doing. It's just a lot cleaner if I don't do the working out for each one of them. Then I'm going to take this one, and I'm going to plus 2 pi to it. So I'm taking 19 pi on 6 and I'm plussing 12 pi on 6 onto that, which is going to take me to 23 pi on 6. Sorry, not 23 pi on 6. 19 pi is going to take me to 31 pi on 6. And then I'm going to take this one and I'm going to plus 2 pi onto it, which is 23 pi on 6 plus 12 pi on 6, which is going to be 35 pi on 6. Perfect. All right, now that I've done that, I've got all my solutions. I now need to write this back into, like, I know A is going to equal to 3 theta. So I'm going to say 3 theta, and now I'm literally just going to write all these down. 7 pi on 6, 11 pi on 6, 19 pi on 6, 23 pi on 6, 31 pi on 6, 35 pi on 6. Then what I'm going to do after that is I'm going to times them all by 1 on 3 to get rid of this coefficient of 3 here. So what I think in my head is I'm just multiplying all the denominators by 3. So all my denominators are going to turn into, whoopsie daisy, are going to turn into 18. So I'm going to get theta is equal to 7 pi on 18, 11 pi on 18, 19 pi on 18, 23 pi on 18, 31 pi on 18, 35 pi on 18. Those are going to be my answers. Let me quickly now show you what this would look like if I was just to graph it on Desmos. So I graphed this sine of 3x, which is here. Then I had negative a half. So as you can see, 7 pi on 6, 11 pi on 6, 19 pi on 6, 20, sorry, why am I saying on 6? 7 pi on 18, 11 pi on 18, sorry, I'm just all over the shop, 19 pi on 18, 23 pi on 18, 31 pi on 18, 35 pi on 18. Those are all my answers, and that's where it stops. Sometimes I find myself saying one thing when I'm clearly looking at something else, which is just a horrible thing to do when you're recording a video. Okay, but hopefully all that made sense. So this is where people become really stuck in this topic when solving trigonometric equations. They find this process really quite difficult, but just give it lots of practice and you'll be fine. I think there might be one more part, or there might not be, but hopefully you found that all that useful. All right, I will see you soon.